Welcome back. We're now on Binomial PDF video number 3. If you remember from the previous videos, we started with a scenario where we had 5 multiple choice questions, and we realized we wrote out all the different ways to get 2 of those 5 correct. We realized there's quite a few options there. And then scenario B, there's 10 questions instead of 5, and suddenly it got a whole lot more difficult, and we didn't even want to try to write them out, and we used our binomial probability distribution functions because each of these events are independent of each other, and there's 2 choices, binomial. Either you get them right or you get them wrong, so that's why I'm allowed to use a binomial probability distribution function here. We have some new questions now when we're looking at this. First question, what is the mean and the standard deviation of this system, of this situation? Again, we're assuming this thing is binomial. What is the mean and the standard deviation? Well, there's a couple of things we can think about. When we're thinking about the mean and the standard deviation, one way to do it would just be to create a distribution table. And if you remember from previous videos, we were doing the binomial probability distribution function. And if I write that out there, but then I delete this piece right here. So there's 10 questions on my test. I have a 20% chance of getting each one of those right because I'm just guessing out of the 5 options. 1/5 is 20% chance. But I'm not asking for a specific value. What's the probability that I get 3 of them right, or 2 of them right, or 1 of them right? I'm going to store it. Store is down right here. I'm going to store that in list 2. I'm going to store that into list 2. And yes, I did put it in list 2 on purpose, not list 1. And if I do that, it spits it all out, and I can't really see much. But if I go to stat edit, all of those probabilities are here. Now, in yours, you probably don't have these numbers here. There's either blank right here, or maybe whatever numbers you had from the last time you used your stat edit. So you need to go in and type 0, 1, 2, 3, 4, the whole way down to 10. But what you can see is you have the probabilities of each of these things being correct. If you remember from before, we said the probability of 0 correct was 11%, right there. The probability of 1 correct is 27%. The probability of getting 2 of them correct is about 30%. So we can see each of these probabilities that we were working on before. Also those ones that we did at the end there. The probability to get 10 of them right, really, really, really small. The probability of 9 of them right, really, really small. So if I want the probability, or if I want to find the mean and the standard deviation, then I can go to stat, calculate 1 variable statistics, list 1. Those are the different things that I've got. 1 correct, 2 correct, or 0 correct, 1 correct, 2 correct, 3 correct, 4 correct, up to 10. And then this is the important part. Don't forget list 2, because they're not all equally likely. It's, getting 2 correct is not the same probability as getting 10 correct. So I need to include the probabilities here for list 2, and I go to calculate. There's my mean, and there's my standard deviation. So my mean is 2, and my standard deviation is this. So again, this is the way I would do it for any probability distribution. It doesn't have to be binomial. I get all that data in there. And then this one happens to be binomial, and that's how I got it in there. If it was not binomial, I'd somebody need to present me with a table of probabilities or something. But this is a lot of work. There's another way to do it. If you look in your text, it says that when you have a binomial distribution function, oops, excuse me, I'm bumping my camera here. When I have a binomial distribution function, I'm looking for the page here. In section 3.4, I'm on page 237. The mean is NP, and the standard deviation is the square root of NPQ. So we need to remember what those things mean. So my mean is NP. Think to yourself, what is N and what is P in this situation? Again, the scenario is that we're doing with 10 questions, multiple choice. There's 5 choices, so you have a 1/5 chance of getting each one right. So what is N and what is P? Pause and think. All right, we're back. N means the number of tries. So in our case here, there's 10 because there's 10 questions on our test. And P is the probability that I get it right. So that's going to be 1/5 or 0.2. So 10 times 0.2 or 1/5 is equal to 2. That means that odds are I'm probably going to get about 2 of them right. Just like odds are when you flip a coin, you're going to get about half of them heads and half of them tails. It's not always going to be that way, but that's kind of what you would predict to be true. I would predict to be true that I'm going to get about 2 of those 10 right, because I have a 20% chance on getting each one right. If I do it 10 times, probably about 2 of them are going to be right. My standard deviation is the square root of NPQ. We already know what N is. We already know what P is. Go look up and see what Q is. So, if you look in your book, in section chapter 5, I think it's back in 5.3, N is the number of items in the binomial. P is the probability of getting it right. Q is the probability of getting it wrong. And it doesn't always have to be right or wrong. It can be win or lose, or it can be probability to get a king and don't get a king if I'm drawing cards, whatever it is. So in our case here, we have 10 options. The probability of getting it right is 1/5 or 20%. The probability of getting it wrong is 4/5 or 80%, 0.8. And the calculator has already told us what the answer is going to be, but if we didn't already do this, we could do 10 times 0.2 times 0.8, and the square root of that is 1.2649. So this is my mean, and this is my standard deviation. So I've used these are really the only formulas in a binomial that you need to use. There's a lot of other formulas that the book talks about. You don't need to remember or use any of those other formulas. These two you should know. These are 2 simple formulas you should know because it's quick to calculate mean and standard deviation. All the other stuff, that's where the calculator comes to play. Back when we were doing the binomial distributions, don't do the formulas, use the calculator. So our next question is, what is the range of normal values? If this is my mean and this is my standard deviation, think about what is the range of normal values. Think about the range rule of thumb. Go look that up. See if you can come up with a range of normal values. So range of normal values, we know this is centered around 2. And I want to think about going up 2 standard deviations. And I want to think about going back 2 standard deviations. And it's possible to be outside of this, but this is what I consider normal, is within 2 standard deviations. If you remember, we think about if it's a normal distribution, about 68% of the time we're going to be in 1 standard deviation, and about 95% chance we're going to be in here. And if this contains 95% of the stuff, there's a pretty slim chance that I'm going to be outside of that. So I've got 2 plus 2 of these and 2 minus 2 of these. So in my calculator I can say 2 plus 2 times this. So that's a 4.5 about. And 2 times 2 minus, I gotta go back up to my standard deviation. oops, I did that wrong. 2 times, I'm sorry, 2 minus, I did it backwards, that's why. 2 minus 2 times, go grab my standard deviation. I never retype numbers, I always go back up and grab them. And I get negative 0.53. So that means that it's like I've given a hug to the likely values. If there's 10 questions on there, it is very likely that I'll get somewhere between negative 0.53 and 4.5 correct. It's very almost expected that I'm going to fall somewhere in that range. So what's that mean that I have a negative here? Think to yourself, what does it mean if we have a negative as one of the boundaries on my expected values? It's not possible to have a negative number of correct answers. So really anytime I go below 0 and I get into negative, technically that's true, but from a practical standpoint, it means it goes down to 0. That means it's not unlikely that I get none of them right. If my minimum was at 0.5, that would mean it's really, really unusual that I would get 0 right. But in this case, with this specific situation, because my minimum expected value or minimum range of expected values goes below 0, that means it would be pretty common or expected that I'm going to have none right. Or it's common that I have 1 right, or 2 right, or 3 right, or 4 right. Anytime I'm in any of those options, that would be common or expected. If I'm way out here, it's not very likely. And we calculated at way, way less than 1% chance that I'm way over here to the right and getting like 80% right, getting 8 of them right. So that's way beyond our expected interval there, the range of normal values. So question, is it unusual to get a score of 50%? To get half of these problems correct? Is that unusual? The question again was, is it unusual to get half of them right? That would mean I get 5 out of 10 right. And we just created our range of normal values. Getting half of them right is over here. We've got a 95% chance that I'm going to be within this interval. To go outside of that interval, we consider it unusual. It's not very likely. If 95% of the time I'm going to be less than 4.5, to be out here, we're dipping into that less than 5% chance. It's very, very unlikely to happen. So if somebody gets 5 of them right, that means that they know something. Either that or they cheated. Anytime anybody ventures outside of this, if they're in here, they don't necessarily know anything. They just were using the probability or getting lucky anytime they got a 0, 1, 2, 3, or 4. But if I venture outside of here, something is impacting that situation. Likely they maybe knew some of the problems and they were able to get them right because of their knowledge, not because of their guessing.